trigonometry has to do with the study of triangles and be able to do calculations. But before we go into that, let's just look and we'll try and draw a triangle that's other than right-angled or isosceles. So if we've got a triangle there, and we'll call it triangle A, B, C. Now A, B, C capitals used for vertexes, and sometimes they are used for the angles as well. So that's angle A in there, angle B, angle C, etc. It's conventional to use lowercase of these letters for the side that is opposite the vertex. So here we've got vertex A or angle A, well opposite that we'll have side A. Here we've got angle B or vertex B, we'll have side B being from there to there and side C over here. And it is a property of all triangles that, looking at this triangle here, will look like angle B is greater than angle A, is greater than angle C. Then the sides will be in the same order. So side B will be greater than side A, will be greater than side C. So that's just a general property, and the opposite is true, or the inverse. So if side B is greater than side A, greater than side C, then the angles will be in the same order. As well as that, you should know that if you add any two sides together, so C plus A, that is going to be greater than the third side. So it doesn't matter which two you choose. So we'll move on now to right angle triangles. And we use the symbol for right angle, 90 degrees. These two angles can't equal 90, or we wouldn't be able to draw a triangle. So if this one's 90, the longest side of a right angle triangle is called the hypotenuse. And if we're interested in this angle here, theta, the Greek letter theta, if you imagine sitting in a room and you're sitting in this corner, you would look at the opposite over here. And down here we would have the adjacent. If you like, sitting in this corner, it's the one you can touch without touching the hypotenuse, would be the adjacent side. So that gives rise to our three trig ratios. Sine of theta is equal to opposite over hypotenuse. The cosine, abbreviated to cos of theta, is adjacent over hypotenuse. And the tangent, abbreviated to tan of theta, is equal to opposite over adjacent. It's always nice to have a way of remembering those trig ratios, and one of them is an acronym SOHCAHTOA, where the first three letters, sine, opposite, so we got sine, opposite over hypotenuse, cos is adjacent over hypotenuse, CAH, and tan is opposite over adjacent, so we get SOHCAHTOA. So maybe that's worthwhile if you have trouble remembering your three trig ratios. An extension to this is what's called the Pythagorean identity. Now you all know that the Pythagoras' theorem is that if this is A, B and C, we've got A squared plus B squared equals C squared. The Pythagorean identity is that sine squared of any angle, now sine squared of an angle is equal to the sine of the angle all squared. We don't put the square next to the theta because that would be a chance that we would square the angle and then find the sine of that. So to take away that ambiguity, sine squared theta is sine of theta all squared. So the Pythagorean identity is that sine squared theta plus cos squared theta is equal to 1. and you can transpose that formula to get sine squared by itself. So sine squared theta, take that over the other side, will be 1 minus cos squared theta, etc. And you could take sine squared over that and so on. So the Pythagorean identity is one that you'll come across not just in this course but in other courses as well. So that's worthwhile committing to memory. So we've introduced basic concepts of triangles and also looked at the 3 basic trig ratios and the Pythagorean identity.